So welcome, everyone. It gives me great pleasure to welcome the people here in the room, as well as those of you out there in the ether world. Congratulations, we've actually got our first hybrid meeting going. Yay! This is a really true pleasure for me because when I first took on the presidency in 2020, I chaired the meeting from this spot in January, February, March, and then we shut down. So it gives me great pleasure that I started my tenure as president with open meetings, and I'm going to be closing it with open meetings. Yes, I'm happy about that. And we're able to do this because of three people that are now sitting in the room. Dave Lane, who's sitting at the controls, Jerry Black, and Bob Russell at the very back, who will be monitoring chat when we come to the question period. So thank you three very, very much for getting this going for today. And oh, not yet. But in any case, so there are some ground rules to be had because this is our first hybrid and we are learning from it. So if things do get a little wonky, please keep in mind that this session is being recorded. And therefore, if you are cut out, especially those of you outside in Zoom, it is being recorded. So you will be able to see the whole meeting on YouTube in a few days hence. Okay, so don't worry if you've missed the latter part or any part of the meeting. Dave, you wanted to mention some things about handling stuff.
Yeah, hoping folks can hear me. Maybe I should have your notes. I was just gonna wing this, but Judy's got notes. Yeah, just so you know how this works. We have about 15 or so people in the room, and we have one camera that Jerry's going to be electrically moving around as the speaker wanders back and forth. And we have Bob in the back row, and he's monitoring the chat. So if, for example, something technically bad happens, like the sound doesn't work or you have a question and so on, do it through the chat. Do not engage your microphone because that will just interrupt the presentation. So that's your main communication method is through the chat. And try to hold your questions or they'll get queued up in the chat. And then after each presentation, Bob will relay those questions to the room and also back to you and to will also end up on the YouTube video as voice. And please remain muted at all times until you want to speak or during the question period. We do have the power to mute you, but that would just be an interruption if you were to do that. So please do that now if you're currently mic on. Yeah, the only microphones we have in this room that you will hear are these wireless microphones and the mic on Bob's laptop. So people in the room, when you ask questions, they will need to be repeated by the speaker. So if you're a speaker, make sure you repeat the question. Otherwise, it will not be heard by the folks out there in Etherland or on the YouTube recording. I think that's about it. We'll give this a try. This is sort of version 1. We hope to fix whatever problems that crop up before the annual meeting in December. So if you do have any comments, I would suggest you send them to Judy after the meeting or any suggestions about how to make it better. Anyway, I'll stop there. Turn off my mic.
Thanks. So again, welcome to November 5th, the second last meeting of this calendar year. To reach us, for those of you that are new to our center, you can go to our website at halifax.rasc.ca. We do have a YouTube channel, and that is the email address for the president. Should you have any questions or comments, please direct them to there, or to any other member of the board if you know who they are and what their email address is on. If you could move it, please. We're going to be starting off with a welcome and acknowledgements, and then Dave Hoskin, somewhere in the room, will be doing the photo montage. And then we'll keep him up front to do a brief introduction to Telescope Eyepieces. Then Dave Lane will do a feature presentation on lights and filters. Dave Chapman will do what's in a name, how celestial objects are named, and his focus will be on surface features of solar objects or celestial objects. Solar system, thank you. And then I'll do something called 300 Things to Know About RASC National Council. Well, really, it's only 3, but that was a nice title, I thought. What's up in the November skies? Dave will explain to us what to look forward to in the coming month. And then we have a return of our resident poet, Paul Heath, for Food for the Soul. We're looking forward to that, Paul. His poem is entitled Painted Images. And then last, we'll have the news from the board. Okay, first and foremost, we do have to acknowledge the Indigenous land rights, specifically of the Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the treaties of peace and friendship, which Mi'kmaq and Maliseet peoples first signed in the British Crown in 1725. The treaties did not deal with the surrender of lands and resources, but in fact recognized Mi'kmaq and Maliseet title and established the rules for what was to be the ongoing relationship between our nations. Next. Also, our particular center and all the centers across Canada do follow the statement as produced by the Inclusivity and Diversity Committee, which reads, all are welcomed regardless of age, disability, gender reassignment, marriage and civil partnership, pregnancy and maternity, race, ethnic origin, color, nationality, national origin, religion or belief, or sex and sexual orientation. We are opposed to all forms of unlawful discrimination. So I think at this point, probably my next slide is the speaker slide, if I'm not mistaken. Yes. So now we have our slate of speakers. So first up is Dave Hoskin, and he's going to do his photo montage. And while he's coming down, I'll give you a brief introduction for those of you who don't know him. He's an amateur astronomer and member since 2018. He's been a board member for the past 2 years. I guess this is actually his 3rd year as a board member. He's our observing chair, and he's Education and Public Outreach, or EPO chair. So, David, it's yours.
Yeah, it may or may not advance. You may have to click it. Go through. Okay, so I've collected a bunch of images off the discussion group and from the Facebook RASC Halifax page for most of October. And so we start off with image by Judy Black of NGC 7822 and Cepheus. Very nice reflection, rather emission nebula. If you just flick them through, David, every 5 seconds or something. And another one by Judy Black, the Pac-Man Nebula, for named so for the obvious reason. Looks like the 80s game. Michael Boshat, picture of the moon, taken from his window. Mike does great stuff, taking it through the window. I think there's another one coming up, the sun. I did these all in alphabetical order, make it easy on myself. And Mars rising over, I think that must be the skyline of Dartmouth. Barry Burgess, a picture of the full animal fattening moon. Barry does great stuff, nice landscape images, and a sketch. Dave Chapman did one of sunspots. So Dave's been sketching a lot. I think I've got a couple sketches. Yeah. Interestingly, I took, you'll see it later on, I took the same picture of the same thing the same day, in fact. And Dave's been also using the BGO telescope to look at, in this case, the orbit of Neptune's moon, Triton, over, I think, 3 days. So the big bright spots, Neptune, and the small one close to it is Triton. You can see how the orbit changes. Okay, someone asked who discovered Triton. I don't know. Dave's looking it up on Google. Lassell in 1846. Okay, so we have a double star sketch from Dave Chapman. You weren't expecting to see this one, right? It just appeared. Okay, Dave says it's a bonus double starred on an older list. Jason Dane is the Zodiacal Light. Falls Zodiacal Light, you have to get up really early. I think he said he got up at 3:30 to take this picture. Heart and Soul Nebula, again by Jason. Sharpless 2, 126 in Lacerta, again by Jason. Very nice emission nebula. No. And Northern Lights. Jason's been really lucky getting shots of the Northern Lights. He took this early October. I don't know if there were supposed to maybe be some last night, but with the near full moon, wouldn't have seen it. Jeff Donaldson from out in Enfield, the elephant trunk. I think he must have been using a Hubble palette for that. This is a popular one, the Ghost of Cassiopeia, emission and reflection nebula, taken by Tim Doucette in honor of Halloween. Andromeda Galaxy by Tim. Lots of nice color there, and you can even see some star forming regions with the red nebulosity. New member Nancy Hughes took this picture of the night sky at the SCO barbecue a few weeks ago, and yep, Mars. Yeah. Lisa Ann Fanning, one of her moonshots, the waning gibbous moon from New Jersey. And I think she's got a nice crescent moon coming up too. Yeah. There's a crescent, so a moon that's just a couple days old. Paul Gray has been doing some planetary work, and he got this really nice one showing shadows of two of the Galilean moons crossing the disk of the planet.
Oh,
now we can do it. Yeah. Just, yeah. There you go. A big picture. Karen Hamblin took this picture of the moon, gibbous moon. I took this picture of sunspots, a very large sunspot group back in early October, done in white light with I think I used my Herschel wedge for it. Dave Lane's asking what the scale of this would be, and I think I read you could fit 10 Earths into it, lengthwise. I don't know, actually. Along the length, yeah. Sun and hydrogen alpha. And that's that same sunspot group on the eastern limb of the sun. To the Pleiades that I took at SCO, lovely transparency that night. Yeah. Blair McDonald, the Wizard Nebula. Yeah. Yeah. Another one of Blair's urban astrophotography images. And Dave Robertson took this image of the crescent moon. Seabright. Grav Singh, the Orion Nebula. Beautiful colors. Kathy Walker, the Fish Head Nebula. Does look like a fish head. It's part of the Heart Nebula. Part of the central portion of the California Nebula, also by Kathy. Very brilliant emission nebula. I see a Ghost of Cassiopeia by Kathy, and I think she must have used a Hubble palette for this. The colors are a little bit different. And Messier 52, that's a nice open star cluster, very compact open cluster in Cassiopeia, and it often gets overlooked because the Bubble Nebula is just next door to it. And part of the Soul Nebula by Kathy. And the Little Dumbbell Nebula. Really small planetary nebula. It's hard to get a good shot of it. And that's it. So lots of nice astrophotography in October. Most of them are off the Facebook page. Yeah. Yeah, RASC Halifax Facebook. I think Jerry and Michael are the only ones that routinely post to the discussion group. Northern, the question was asked where Jason Dane got the Northern Lights picture, and I believe it was in Nova Scotia. Okay, eyepieces. This should be, this one should load easier. Okay. So this is a short presentation on telescope eyepieces, and did a bit of research on it, putting it together, and the takeaway I got was, who knew there were so many different types of eyepieces? Okay. So I'm going to flip the next one, Dave. So when you're going to choose an eyepiece, you want to know a few things. You want to know which objects you plan to observe, because some eyepiece types are better for wide field, deep sky objects, and whereas others are better for lunar or planetary viewing. What's your tolerance for optical imperfections? So are you turned off if you see a little bit of chromatic aberration or lateral color imperfections or not? That'll depend on how much you're going to want to spend on your eyepieces. Is a wide field of view important? Do you wear glasses? So a lot of eyepieces, especially at the shorter focal lengths, don't have very good eye relief. So if you wear glasses and wear your glasses when you're observing, that can be problematic. And how much do you want to spend? So you can spend from anywhere from $10 on a cheap Kellner eyepiece from China to hundreds of dollars for the top of the line Teleview or Explore Scientific. Just a few important equations to know. Eyepiece magnifications, focal length of the telescope divided by the focal length of the eyepiece. The maximum useful magnification it will be 50 times the telescope aperture in inches, and that's being pretty generous. That would be under excellent seeing conditions. For Nova Scotia, it's probably more like 30 or 40 times. The largest focal length eyepiece that you can use without eye loss. So that's going to change depending on the size of your dark adapted pupil. So if you're 20 or 30, your pupil probably dilate to 7 millimeters. If you're in your 60s or 70s, you're probably looking more at 5. So that'll change whether, I mean, you could still use a 32 millimeter or 40 millimeter eyepiece, so you're just not going to be getting all the light into your eye. And then the true field of view is the apparent field of view over the eyepiece magnification. So we'll start with eyepiece sizes, the next slide. Got 3 common eyepiece sizes. There's the little guys, the 0.965 inch eyepiece. This used to be the standard eyepiece in older telescopes. If you buy a classic 60 millimeter refractor or a small reflector, those are the eyepieces you're going to get. And just notice how the glass size changes. 1.25 inch eyepiece is the most common size now in the middle. And the big guy, the hand grenade, is a 2-inch eyepiece, but you need a 2-inch focuser to use those, but they're huge. That particular one, literally it's hand grenade sized, very heavy. You want your eyepieces to be fully multi-coated in order to reduce reflections and light loss. And there has to be lots of blackening, both in the interior of the barrel and on the edges of the lens elements to reduce reflections and increase contrast. So those are things to look for when you're pricing eyepieces. So some of these designs are old. The symmetrical Ramsden design is from the 1700s, and it consists of 2 lens elements arranged, shown on the top. Lots of drawbacks to these. The very restricted apparent field of view. There's sharpness decreases quite dramatically towards the edges, and there's lots of lateral color error. These were the typical high power eyepieces supplied with older telescopes, but even Celestron sticks them into some of their current models. I don't know why they just do that. They're pretty useless. Throw them in a drawer. That's a Celestron SR4 millimeter. Look at the tiny lens you're looking through. You can just imagine what the field of view is. Next one is the Huygens, designed in the 1600s, so even older, by a Dutch astronomer. It also has 2 elements, restricted apparent field of view, poor eye relief, again, some lateral color issues. It was the typical medium power eyepiece with older telescopes, but it still crops up in modern telescopes. So that's a modified Huygens 25 millimeter eyepiece. That's okay. We're done. So now we come to the Kellners. These are of the eyepieces that I was looking at. These are the first ones to be reasonable for modern telescopes, especially if you're using something with a longer focal length. Designed in 1850 by Carl Kellner. You find them in all 3 eyepiece sizes. This has 3 elements in 2 asymmetric groups, and that eliminates color fringing. You go back, you flicked it. Is it? Oh, it shouldn't be. Oh, maybe it is. Okay. It's telling me to speed up. Field of view, apparent field of view is 40 degrees, so not too bad. Moderate eye relief. There's good center sharpness, but not so sharp at the edge of the field of view, and there's some lateral color error. It was the typical low power eyepiece provided with an older telescope, but you still find them quite often in modern telescopes as your beginner eyepiece. They're sometimes referred to as a modified achromat. Skywatcher gives you a 25 millimeter and a 10 millimeter. They call them super wide angle eyepieces, but they're actually Kellners, so they're not that wide angle. Next one is orthoscopics. So these are nice eyepieces designed by Ernst Stabbe in 1880. They have 4 lens elements in 2 asymmetric groups. Better field of view, apparent field of view is 40 to 45 degrees, but the eye relief is not very good. So you wouldn't choose these if you're wearing glasses for the most part. But nice tack sharp images, flat field, well corrected. And you can find them from sold by Batter Scientific and University Optics. So they're recommended for lunar, planetary, and double star observing. There's a variation on this design marketed by Burgess and TMB Planetary with a wider field of view and better eye relief. Colossal eyepieces. So this is the workhorse. Okay, this is what most people this would be their first upgrade in terms of an eyepiece. 1860s, designed by George Simon Plossel, 4 elements in 2 symmetrical groups. The apparent field of view is 50 degrees, so pretty decent. There's adequate eye relief at higher focal lengths. Once you get down the shorter focal lengths, 10 to 12 millimeters, then the eye relief starts to decrease. They require multi-coatings and barrel and lens edge blackening to prevent reflections. So don't buy cheapy Plossels because they probably don't have the good multi-coatings and you get lots of reflections when you look at brighter objects. But these are the mainstay of modern 1 1/4 inch and 2 inch ocular. So they're good value. Then we come to wide angle eyepieces. So these are you're starting to get pricey, 6 to 8 lens elements in 2 or more groups. So pretty complicated engineering. The field of view ranges from 60 to 100 degrees. So nice, super wide views. They tend to be large, quite heavy, and they often incorporate low dispersion glass as part of the lens elements. So the Celestron Excels are kind of the next, for me, it was the next step up from the Plossels, about 60 field of view and nice sharp images. And then you go to expanses. They're wide, they're 60 degrees field of view, but I don't find them all that great. Next one, Erfel eyepieces. So these are some examples of the more premium eyepieces. Erfel's designed from around World War I, 5 to 6 elements in 3 groups, 60-degree field of view, good eye relief, a flat field, but not quite as much sharpness and contrast as you see with the 4-element designs. They're marketed by Mead and Burgess Optical, and they're recommended for wide viewing. That's okay. We're on to the next one. Nagler, designed by Al Nagler, who's head optics guy at Teleview. 6 to 8 elements in 4 or 5 groups, and they include a built-in Barlow lens. There's a very comfortable 82 degrees of apparent field of view with good eye relief, and these are the gold standards for short focal length 1 1/4 inch and 2 inch oculars. Radians and Panoptics have shorter and wider apparent fields of view, and they're also sold by Teleview. Just to give you a sense of what this apparent field of view, the differences it can make, it switches to the next one. There we are. So looking at the moon, this would be what you would see with a Kellner, 40 degrees, and then a Plossel. And then you can see as you go up in the apparent field of view, more and more of the image appears in your field of view. And once you get up to the 82 degrees at the same focal length, you're seeing the whole lunar surface. Another comparison, Plossel compared to one of the more premium wider field eyepieces of the Andromeda galaxy. Zoom eyepieces, just a quick word about them. They're tempting. They, you see one and say, well, you can just get one zoom eyepiece and I don't have to buy a whole bunch of fixed focal length eyepieces. They are affordable generally. And you can they allow you to adjust the focal length of the ocular to make the best of the current seeing conditions. But color correction, contrast, and sharpness are inferior to fixed focal length oculars. And the biggest drawback to these, to me, is that at the longer focal lengths, so they tend to be 8 to 24 millimeter focal lengths adjustable. At 24 millimeter focal length, your apparent field of view is only 40 degrees, so you basically got a Kellner. And you want longer focal lengths to see more because you're trying to find something that you can then hone in on. But they are available, and if you just want to have a quick grab and go setup and stick one eyepiece along with it, and get a zoom eyepiece. And lastly, Barlows and focal reducers. These are used to increase the effective focal length of a telescope, and so your magnification will change for a given eyepiece. The nice thing is that it allows you to retain the eye relief. So if you wear eyeglasses and you're having a hard time with a 10 millimeter focal length eyepiece, take your 20 millimeter focal eyepiece and put a 2 times Barlow in it, and you'll still have that eye relief, but you've effectively turned that into a 10 millimeter eyepiece. So you double the magnification. There are numbered designs. The simplest ones use 2 elements. There are also 3 and 4 element designs. They're available anywhere from 2x to 5x. There is some light loss because you're having light move through extra glass. And there will also be magnification of any color error due to the telescope ocular combination. Now, a really neat trick, though, is that if you buy a Barlow like this 2 times Orion Shorty, that lens element can be removed and screwed into the bottom of an eyepiece. That will give you effectively about a 1.5x Barlow. So if you're having problems, especially with a Newtonian achieving focus, you can use this little trick. And I think that's the last one. Yeah. So, any questions? The question was, do you have to refocus when you change the zoom on the eyepiece? And it depends on the zoom eyepiece. Bader has their Hyperion zoom eyepiece, which is like $300 or $400, and it's keeps the same focus across the entire range. Celestron comes into the cheap end, and I think that you have to tweak the focus as you go through. Gary? So the question was how focal length interacts with apparent field of view, and Jerry's referring to the slide I had. It was near the end, I think 3rd or 4th from the end. So that is I think these images were taken with an 8-inch Schmidt-Cassegrain, and the magnification is actually the same, Gary. So they were all taken with same focal length eyepiece. So say, I don't know, maybe it was a 20 millimeter. But you can see how, here you've got Pico and Sea of Serenity and Tranquility, but not much below or above. And then as you increase the apparent field of view, you're seeing more and more of the moon. But look at the size of Pico; it's the same in all the images.
Okay. So there's a page in the handbook which deals with magnifications and focal ratios and all that. And you can figure it out from reading that. So the apparent field of view is a property of the eyepiece. It's got nothing to do with what telescope it's in. It's when you look in the eyepiece and just look up at the sky, that's the apparent field of view, so many degrees. The actual field of view is that apparent field of view divided by the magnification. Okay. And the magnification is determined by the focal length of the eyepiece and the focal length of the telescope. In this case here, the focal length of the eyepiece doesn't change, and I assume it's the same telescope. So the magnification is the same here. So the apparent field of view scales, sorry, the actual field of view scales with the apparent field of view. Okay, so it's a little bit of arithmetic there, but it's worth studying that one page.
Okay, so Greg was asking about light loss when using a Barlow, and you do get a little more loss because of the extra glass, but the object is mainly dimmer because you've increased the effective focal length, right? So if you look at the moon through a 25 millimeter eyepiece, it won't look as bright if you switch to a 12 millimeter eyepiece. Okay, so there's that kind of dimming. So you can think of it a bit as changing your f-stop with a camera lens.
So then if you go from a 20 millimeter to a 10 millimeter, then it's going to be basically the same as going from the 20 millimeter with Barlow.
Yeah.
So there's no.
Not much. With the modern Barlows, there's the coatings and the quality of the glass. Really, maybe there's a couple % light loss, but so again, we're just talking about how much light loss you're going to expect with a Barlow. The Barlows come in different levels of quality. The cheapies are pretty bad. The best kind of beginner Barlow would be one of the Orion Shorty or the Celestron Omnis, and then you move up. Teleview's Barlows are very expensive, but they're a step above. Same thing. Explore Scientific has the focal extenders, same thing as a Barlow, and they're a lot more expensive. So say $50 for a Celestron Omni versus $200 for a Teleview or an Explore Scientific.
And are you paying for better glass?
Yeah.
More expensive or a different design?
Better glass, more glass. So the cheapest Barlows just have 2 elements. The intermediate ones have 3, and the most expensive ones can have 4. But it's mainly better glass and better coating, multi-coating.
When you're using a Barlow, effectively, you're looking for an increase in focal length. Light loss is minimal, or not a concern. You're looking at smaller objects that you need that magnification for. So typically planets. So light loss doesn't play in. If you're doing astroimaging of planets like I've been, you want the Barlow for that increased focal length. Purely, that's what it is. The little bit of light loss doesn't matter. The deep sky objects, very rarely do you use a Barlow for, because you're not trying to get down to that sub arc minute or a couple arc minute detail. The only time I would think of that would be for planetary nebulae, which you can get some of those that are in a half, 30 arc seconds to 1 or 2 arc minutes, in which case a Barlow helps. But the advantage there is planetary nebulas also have normally a high surface brightness. So they can take that increased magnification. I recall once using a 25-inch telescope with a 2-time big Barlow on a 9 millimeter Nagler, looking at the dumbbell at some god awful 700 power. Actually, no, it was the Owl Nebula at 700 and something magnification, and it was amazing. But again, light loss is minimal because you're looking at a high surface brightness.
And if you're imaging, you can compensate for the light loss just by changing your gain or the ISO. Okay.
So, thank you, Dave, for that. I'm glad there were a lot of questions because you certainly asked the ones that I certainly had in mind. I'm sure other people as well. Next up is another Dave. If you looked at the agenda, you'll notice there's Dave Hoskin, Dave Chapman, Dave Lane. I felt like I'm actually at the Royal Astronomical Society of Daves rather than of Canada today. But anyway, Dave Lane himself, well, he's professional as well as an amateur astronomer. Pardon me? Oh, he says not anymore. He's been a member of the RASC, believe it or not, a longtime member since 1986. He's also a fellow of the RASC, and he served many roles both here in the center as well as across the country. He currently serves on the RASC Observing Committee and, whoops, wrong one. My apologies.
Okay.
Wrong Dave. He retired from SMU. That's why he said he was an ex professional. Yeah, that's right. See, Dave and Dave is confusing. I'll put my finger there so I know which one I'm introducing. He certainly has been our website webmaster since we've had the site up and running, as well as our distribution list administrator for us as well. And he's currently sitting as our center's auditor. So thank you, Dave, for that. And his talk today is light and filters. So take it away, Dave.
Okay, thank you, Judy. Not sure how I'm going to advance the slides, but let's just see if they even advance at all here. Okay, I gave this talk or something quite similar. Actually, it's almost identical. About 5 or 6 years ago at Inova East. So I apologize to those who have seen it before, but it seemed to relate to the last presentation on eyepieces. So I'm going to talk about some of the properties, light, plus how it relates to using filters for visual astronomy. We're not going to talk about imaging or anything like that. It's just what you would attach to the eyepiece that we just heard about in the last presentation. So generally talk about why we use filters, a little bit about the visible spectrum and what we're actually trying to see, and some of the a little bit about the eye, and talk a little bit about astronomical light sources. So what actually comes from the sky that we're trying to see, and what its properties, what their properties are, and the types of filters that we typically find, how we use them, and of course questions at the end. So if you can just hit the button there. Why use filters? Well, a number of reasons that I could think of was sometimes things are too bright and you actually want to make the images dimmer. And the obvious is the moon. If anyone's looked through a big telescope at the moon, you walk away from the eyepiece with this big ball burned into the back of your eye, and I've been told that it goes away eventually. We tell this to people at the BGO, at the observatory upstairs. Don't worry, you'll see this big thing there. It will go away. We haven't been sued yet for damaging it. So you might use a filter to actually make something dimmer. You might want to take something that is a color, that has a color feature that you want to enhance or de-emphasize a particular color to show some sort of a feature, or a contrast enhancement. And last but not least, you might want to try to filter out some wavelength coming from light pollution more preferentially than the light that you're trying to see through the sky. So those are generally the three reasons why you might want to use a filter, because filters dim things. That's what they do. So unless you're going to get some benefit, why would you make the light dimmer? Okay, so the electromagnetic spectrum. So this is your physics review, down at the very high, small wavelengths, tiny, like 0.1 micrometers. Is that what that says? Not sure whether that's, yeah, nanometers, all the way down to the other end of the spectrum. Radio waves, long as a kilometer or so, the wavelength. Somewhere in the middle there is the visible light. That's what our eyes see. It is a very, very, very narrow part of the electromagnetic spectrum. See it divided out here at the bottom in the colors. Practically speaking, we really only see at night quite a narrow range of this anyway, of the visible, of the full color spectrum that we might see in photography. Our eyes generally don't see a lot. The other interesting thing is that a lot of our atmosphere actually blocks big parts of the electromagnetic spectrum, and that's why we have things like space telescopes to go above the Earth's atmosphere to pick up things like gamma rays and X-rays and such a thing. But the visible light does make it through the surface, pretty much, and parts of the radio spectrum and parts of the infrared do make it through the atmosphere. But of course, we can only see with our eyes the vision, what we call the visible spectrum or the visual spectrum. Next. So the eye. The eye behaves differently depending on the light level. As most of you probably know, our eyeballs have two kinds of light sensors, the rods and the cones. In the daylight, it's mainly the imaging of what we actually see comes from the center of our, or at least the visual acuity is the center of our vision where the cone cells are concentrated. And they call that the photopic vision. So that's the daylight vision, bright light. We see color. It's surprising how terrible our eyes really are. When you stare at something, you can see something very nice here, but if I had my hand out here, I can see my hand. I know something's happening, but I have no idea how many fingers I have up. Just the way the eye works. What we're concentrating on, our brain does the processing and sees a good quality image. We basically are all worse than Kellner eyepieces, I guess, or Huygens. In low light, everything changes. The cones are not very sensitive to low light, and are the rod cells, which are concentrated more in the periphery of our vision, become the dominant light detectors, and they call that the scotopic vision. Now, one other thing that happens is the sensitivity changes. So, and this graph shows the sensitivity of our eye to the photopic bright light and the scotopic, the faint light. And what happens actually is our sensitivity actually shifts towards the bluer colors in the day, in the nighttime, which comes into play a little later on. We start looking at what we're actually seeing when we look at an image like an object like the Orion Nebula, for example. Yeah, so that's the main thing that happens is we get a shift. We get different sensors in our eyes coming into play, whether it's a daylight or a bright object versus a nighttime situation. Next. The other thing is, so what about the light that actually comes from the sky we're trying to see? And there's generally two types of light that we see. We see what's called a black body, or anything that has temperature in the universe produces light in a characteristic shape known as a black body curve. The hotter something is, the more shorter the wavelength, or the more bluer the object is. And in case of things that we might like to look at, like stars, so black body is a continuous spectrum. All the colors are there. So this is a curve of intensity versus wavelength or color. So that way is blue and this way is red. But this area is actually infrared. This is the part our eyes see, the visual spectrum. This is in ultraviolet, which we don't see. Stars, depending on their temperature, produce a different appearance to our eyes. So not surprisingly, if you take a very hot star, like 12,000 Kelvin star, its graph puts out more light in the blue than in the red, so it appears bluish when we look at it. In the case of a very cool star, 3,000 Kelvin star, like a red dwarf, it produces more light in the red end of the spectrum than the blue, so it appears red to our eyes. But it's not a red star. It's not only producing red light. It's producing all of the colors of the spectrum, but it's producing more light in the red, so that's why it produces. And somewhere in the middle, like a 6,000 Kelvin star, which is not too far off from what the sun is, it's would just kind of appear, I don't know, whitish, no real dominant color. And we don't see colors very well at night anyway, because the rod sensors do not detect color. So the only time we really see color through an eyepiece is if the object is very bright. so a very bright star, or if we have two stars side by side that are quite opposite colors, and our brain has something to work with, and it can see the difference. And like Albireo in the constellation Cygnus would be a good example of that. Another one is what Gamma Andromedae. That's the end of one of the lines of the Andromeda constellation. Is also a great double star that shows you this contrast of the colors. It's great to show people through a telescope a double star like that, because you can ask them, well, what colors do you see? Because everyone sees things a little differently. The other type, actually, getting beyond stars, or getting beyond this black body, there's complications, because stars aren't perfect black bodies. They have an atmosphere, and the atmosphere, depending on its temperature and chemical composition and so on, actually absorbs certain colors. They call those dark lines or absorption lines. And so the spectrum, this sort of simplistic line here is not what we see in real life. But it's for the purposes of just looking at a star, you don't see much difference. So actual sources of black bodies are stars, clusters of stars, galaxies. Galaxies are basically stars. That's what we see anyway. Can't see dark matter. Objects are visible by reflected light. So in other words, objects that are lit up by stars, such as planets, the moon, reflection nebulae, they would be these black body radiators. So the next slide. Here's an example. So this is a spectrum, wavelength, red on this end, blue on this end, of an actual star, Delta Cas. So it's got that general shape that we see over there. It gets brighter in the bluer because it's a blue star. But all of these dips are, in this case, they're actually caused by hydrogen. There's a hydrogen bomber series. Now, you couldn't see this if you looked at the star. You wouldn't notice it. It would still appear as a bluish colored star. But using a spectrograph, you can actually see the chemical elements in a star. Quite simple, though, just individual lines, not much going on there. The next slide shows an M star, or a cool star, hopefully. Yeah. So here's the exact opposite. So this is Alpha Orion, which is what? Betelgeuse, right? Yeah. So in this case, puts out almost nothing in the blue, incredible amount of light in the red. That's why it appears red, but it also has a lot of lines. There's so many of these absorption lines. They're all over top of each other, just a mess. You can't see that, of course, but again, you see a reddish trend to it. Next. The other type are what's called emission sources. And these are typically emission nebulae. I wonder where that came from. M42, Andromeda Galaxy, or Orion Nebula, M8, which is the Lagoon, planetary nebulae, M27, M57, Ring Nebula, etc. These are emission sources, which means they basically produce light in only very specific wavelengths or colors, and often only a few of those colors at any brightness, because they're coming from the gases that are in the nebulae. So if you think of an object like Orion, the Orion nebulae, there are bright stars contained within it that are incredibly hot, and they produce a lot of ultraviolet radiation that's absorbed by the gas surrounding them, and that heats the gas up. The gas then cools and emits light, invisible light, due to the gases that are contained within them. So in the case of the Orion Nebula, we're talking about mostly hydrogen. There's also other elements too, sulfur, oxygen 3, and so on. So if you look at a spectrum, I don't even know what this was. Hydrogen, this is a hydrogen spectrum. So this is what would be produced if you had a very, very thin hydrogen gas in a lab. If you ever played around in a physics lab, they got these gas tubes. They go in a little box. You put a few hundred volts to them and they glow. It causes the gas inside the tube to become, well, it's the same thing as these crazy things here, these fluorescent lights, same idea. So you get hydrogen alpha, beta, gamma, delta. This is the blue end, that's the red end. So if you take a picture of the Orion Nebula, you see, generally speaking, you mostly see the red color, right? What do we see if we look ourselves? Does anyone know? What would our eyes pick up? Yeah, okay, you got a really big telescope. You got that 25-inch that Paul was looking through earlier at quite low magnification. Do you see any color at all? A little bit of green, yeah. And the reason is because the eye is basically blind to the red light. We went back a couple of slides, you see the red end of the spectrum at night, our eyes just don't work. They don't see that red light unless it's incredibly bright. But the peak of the sensitivity of our eyes at night is actually in the green, and the green is where the hydrogen beta is, and it's also where oxygen 3 is. So that's generally when we look at an emission nebula like the Orion Nebula or any of the others like it, we're typically seeing the green light and not the red. So we're not seeing what the photograph picks up necessarily. And in the case of planetary nebulae, they actually, most of the pictures we see of planetary nebulae usually appear more green than red. I think the Ring Nebula is probably the exception, but some of that may have to do with just the way film works in the old days. But most of them now appear more greenish, and that's because there's just more light coming out in the oxygen than in the hydrogen beta than in the hydrogen alpha. Okay, next slide. So here's a graph. I got to throw a graph in. So this is what a spectrum would look like of a real object. This is the M57. And when you take a spectrum, you usually see, actually we're seeing kind of a cross section through the nebula. So you think of it as a circle, we're getting the two parts of it here. But if you turn it into a graph, you get hydrogen alpha, a couple of nitrogen lines, you get oxygen 3, two oxygen 3 lines, and hydrogen beta. And these are the ones you're actually seeing with your eyes. You can't really see that one because the eye is not sensitive enough. So this kind of object really lends itself to have its images improved, or what we see improved. Because remember, when we're looking at an object like the Ring Nebula, it's sitting on top of a bright sky. The sky is not black. It's, with light pollution, it's gray, bright gray. Head out to St. Croix, it's darker, but the sky is never really black from the Earth. There's glow in the sky. So you're constantly trying to see a faint object over top of a not black background. So if you can do something to make the background darker, you can see more. And that's where a special type of filter we'll talk about in a couple of minutes comes from, and that's the nebula filters. But I'll leave that discussion for a bit. But that's just remember what we're actually observing. We're observing an object that only produces light at very specific wavelengths. Next. Okay, so light pollution. Light pollution, and we were just talking about that. The sky background is not black. This is a spectrum of a typical sky background caused by two light sources, high pressure sodium, which were the old style street lights. We don't really have too many of them around anymore. And LED street lights, which is the modern one. Look at the difference. Nova Scotia, when I gave this is the line I changed in the talk from 6 years ago. 6 or 7 years ago, we didn't have LED streetlights. So we were really talking about light that looked like this coming from the streetlight. So that's 600. I guess that's more like a blue, red, blue, amber color. They had a little bit of a orangey tint to them. And then they threw a little bit more of that color in just to make it a little bit more whitish. But generally, they were kind of an orangey, yellowy kind of cast to them. If you wanted to block this, you could build a filter to notch that out, and that would make your sky a lot dimmer. Look at the LEDs. They're all over the spectrum. So it's almost impossible to filter them out. That's the problem we're dealing with today. So this makes the sky bright, makes the contrast lower, makes it harder to see things. So that's why we're going to talk about what are we going to do about it with filters. Mercury vapor, we don't see too many of those around anymore. They used to be popular 20 or 30 years ago. You find those more in yard lights, places like, because you can buy a really cheap mercury vapor street light from Home Depot for 150 bucks. It'll light up your yard and your neighbors too. And they're quite efficient, electrically efficient. That's why they use high pressure sodium. They're just way more efficient than incandescent light bulbs. That's why they had used them for many decades in streetlights. It's because they're just, you put a lot of light for a relatively small amount of electricity. LEDs are better, efficiency wise, not for astronomy. Okay, next. Types of filters. So now we actually, what do we have available to us to make things better? Well, to make the things dimmer, like the moon, we can buy a neutral density filter. So that just dims the light equally in all wavelengths, makes the object dimmer, but doesn't change its color. And there generally are two types of those. There's just basically a piece of glass with a dye in it that just makes it dimmer. They call those neutral density filters. And they're usually spec'd by a certain percentage, like 50% or 25 or whatever. The second are a polarizer. So most light coming from the sky is polarized in some way. So if you can rotate the filter, you can vary the dimming. And sometimes you can buy a polarizer that actually has an adjustment right in it. So you have two polarizing glasses that you can rotate with respect to each other, and you can really dim them down to something like maybe even 5 or 10%, and you can vary it. So that's what you might use on the moon if you have a big telescope. That's what we use at SMU. We have, I think, two filters. One is like 25%, and one is 50%, and I think we usually stack them. And so 0.25 times 0.5 is 0.125, so it would be about 1/8 of the light would get through. Colored filters. Well, they're generally used for planets. I've got a couple of examples here. I'll just hand around to the room. Apologies to the folks who are not here. But these are filters that are quite cheap. You can usually buy them in sets. And they're used for looking at different features on planets generally. And so I've got two here. I got a red one and a light blue one. So you want to just have a look, hand them around. They're cheap. Don't worry about it. I've never used those. I think I got an example in a second. I think the next slide actually shows the general uses you might use them for. Those ones actually belong to former member, some of you may remember, Clint Shannon. He gave me a bunch of his stuff just before he passed away, and his filters were in that box in my basement. So the idea is they're inexpensive because they're basically just glass with a dye. They're not complicated to make. You can get a set probably for like $100, maybe a set of 8 different that may thread into the bottom of an eyepiece. The result is you make coarse changes to the color. You may enhance blue or de-emphasize red or let through green but not red and whatever. So it's generally broad, coarse changes to the color, changing the tint of something with the hopes of enhancing some feature and de-emphasizing some other feature. So like, for example, you might use, and I'll get this wrong, shoot me. Let's pretend you can use a red filter to see the red spot. I think that's actually not the case on Jupiter. That's one example. Actually the opposite. You'll see in a second, I have a table that shows you the recommended filters. And every person's eye is different. So, what works for you may not work for someone else. The disadvantages is their peak transmission is low. So you wouldn't want to use them, looking at a galaxy to, enhance or de-emphasize light pollution or some crazy thing like that. I just wouldn't want to, because they only let through a fraction of the light that you're interested in. The second type are probably more common. I remember maybe 25 years ago, Pat Kelly's probably remember this. He's out there in the distance. If you had an ultra high contrast filter at Nova East, you could get in the front of any line. They were expensive and they were not that commonly owned, and you could get in the front of the line of a big telescope just by saying, "I've got the filter." Anyway, so they're difficult and expensive to make, and that's because they are designed to let in only very specific wavelengths of light. So they make them by depositing in vacuum chambers, depositing layers of dielectric in precise thicknesses, such that light itself isn't absorbed. It actually bounces back and forth between the layers and either constructively or destructively cancels out or it adds, so that essentially the light you're not interested in gets reflected away from you, and only the light you're interested in gets through. So as you can imagine, this is expensive, complicated to design, even more complicated to make, and that's why they typically cost, say, between $100 and $300 per filter. And some examples would be, I think I might have information on that later, so I won't say, but the resulting is you have very fine control over the, or narrow band is the other word they use. And they work, they're really reflecting. Here's an example. I'll hand this around. Be careful with this, that don't touch the glass. This one I care about. Doesn't get me the front of the lines anymore. This is an oxygen 3 filter from Lumicon. So if you look through it at the sky, you will see red. And of course, that's going to be exactly opposite from what I just said, right? You can't see it. Well, of course, you can see the red in this room because it's so bright. But in the real sky at night, what you wouldn't see through here, if you looked at a bright star through this, you'd see green, because you'd see the oxygen 3. It turns out some of these early filters, even though they're called an oxygen 3, which should only be green, they leak light in the red. They're not perfect. The newer ones are better. This is probably 30 years old, but you've probably seen this. But you'll notice it looks like a mirror because it basically is reflecting back most of the light, not just letting light through. And they typically have very high transmission, like greater than 90% at the wavelengths they're designed for. Almost zero in the wavelengths they're not designed for. You want next slide? Yeah, so here's examples of some of the uses you might use one of these planetary filters with. So let's see what this example, I didn't write this, I stole it from somewhere. Oh, source. Starizona, great astronomy retailer down in Tucson. They have a lot of information on their website. So is there something there for, yeah, orange and red features on Mars. Yeah, light yellow. Seems kind of counterintuitive, but makes those things darker. Yeah. Yeah. It changes the contrast. Right. Yeah. And some filters are actually useful for another reason too. Telescopes are much better than they were 25 years ago. Particular refractors. The color correction in the refractors is way better than it used to be. So in the older days, when you look at a planet, you'd see color fringing and all kinds of stuff. So you would actually use a filter, and what it does is it would narrow the band, the width, the amount of range of colors getting through the telescope. So it could actually make the object brighter. Not brighter, sorry, sharper, or it could also, improve the contrast because you don't have colors sort of being blurred through, being blurred into existence by the fact that the refractor maybe only had 2 glass lenses instead of the current 4 lenses of a modern refractor. So they were used for that purpose in the older days. Now newer refractors are just so much better than they used to be. Of course, they're also a lot more expensive. Okay, let's go to the next one. The light pollution filters, or the, so this is another kind, the light pollution filters. Now, these were more useful with high pressure sodium streetlights than they are now. I honestly don't know whether does anyone use light pollution filters now that we switched to LEDs? They're probably useless because these were designed to let through. You remember that, I should have superimposed it, but you remember that high pressure sodium over in the red-ish and the yellow red had a whole bunch of things here and nothing much here. So what it does is it lets through the light and blocks the light where most of the light coming from the street lights were. But now with an LED that sort of covers the whole spectrum, these things are probably just a waste of space in your eyepiece case now. because yeah, here it was blocking all of these. Hg is mercury lines, sodium. You can't really see anything when you're close to this. Hydrogen alpha is here, so it let through the hydrogen alpha light, let through the beta and oxygen 3, and so on, and block the mercury lines at this end. So that was the intent of an old sky. This was the deep sky filter, which Lumicon started making probably about 1990. I don't think I have one of those anymore. But they were useful for photography, and they were also useful for visual. But I think now they're almost a waste of time, would be my guess. Next. Narrowband filters. So the most popular ones are, they have different names depending on the manufacturer. When Lumicon came out with the first ones 30 years ago, they called them a UHC and an O3 and an H beta. This one I think is $1 sign. This one is $2 signs, and this one was $3 signs. This one definitely got you the front of the line if the telescope was pointed at the horse head, because that's basically, this is a horse head nebula filter, useless for just about anything else. But it allows you in a medium-sized telescope to actually see the horse head without standing on your head and lying. You from a dark sky, you can actually see the horse head nebula, and no other filter can let you see that, because it only lets through the color of hydrogen beta and not the neighboring oxygen 3. UHC lets through both hydrogen beta and oxygen 3, and if it's not that good, it'll let through H alpha too. Oxygen 3 just lets through the oxygen 3, but not the hydrogen beta. So the sum of these two is this one, basically. And what works with different objects? Well, it varies, and there's no real pattern. Sometimes these, like the North American Nebula, is great through an O3, but less so through okay. The general purpose one is the UHC, ultra high contrast. The more specialized ones would be the O3 and the H beta, but the more specialized one that's more commonly around, the O3, is good for some objects and not for others. And you can see O3 works really well with the common ones: Orion, Lagoon, Eagle, Swan, Veil, and so on. You will see the Veil through a UHC, but it won't be as good as an O3. Just the way it is. Next. So here's what the spectrum of the filter might actually look like. So this is a Bader H03 filter. So basically lets through no light everywhere in the spectrum except for the narrow area around 500 nanometers, which is where the O3 lines are. There's two lines close together. And why does that work? You're letting through, you got an object that's producing basically only a O3 or mostly O3. You're letting through O3. Why would it be any different? Anyone have any idea? Why would it be any different to look through a filter that looks at an object that's only producing O3 with a filter that only sees O3 versus no filter at all? It could increase the sharpness, but usually the things we're looking at are more diffuse, so the sharpness doesn't matter. Everything else is dimmer because the sky background is this broad band spectrum of either light pollution or glow, sky glow from just natural sky glow, maybe moonlight scattering off or light pollution. All of those things make the sky not black, gray. So if you can lower that, all of the other wavelengths except for the one you're interested in, the contrast goes way up. So you're not seeing any more. You're just getting rid of the noise, the background. And that's basically what these line filters or these narrow band filters do. And yeah, okay. So just to end, a few places you can read up about this. We're right up to date, 2023 Observer's Handbook. Page 64, there's a filter or an article written by none other than Roy L. Bishop about filters. Talks about all these concepts and how they work, and there's also a graph, a plot showing you the different wavelengths and trace lines through actual filters. In fact, that filter that was handed around a long time ago, I wandered up to the chemistry department and actually traced that filter through a machine, through a chemical machine they use in the chemistry department for testing absorption of stuff, and made an actual trace of that filter and the UHC and the deep sky, and then Roy incorporated that into his article. You can also go and look at the manufacturers' websites that sell these things. Lumicon, Batter are the two big ones. Orion makes a number of filters as well. But the important thing to take away is that a filter is a filter. It takes away light. It never adds light. Hopefully, by taking away the light you're not interested in is better than all of the light there. So that's the whole point. But it does make things dimmer. Hopefully, you're dimming things you're not interested in more than you're dimming the actual object you are interested in. Don't go out and buy a bunch of filters sight unseen. People have these things, borrow them at Nova East or at St. Croix. Try them on your own telescope before you buy them. And the last thing I just want to mention, remind again, is that the eye is almost blind to hydrogen alpha. So you don't see the red in things, particularly nebulae. They're just too dim for the eye to see. So really you're looking at the other non-hydrogen, for the most part, features in these nebulae. So you actually will be green. How many have actually seen the Orion Nebula as green and greenish in color? I know Paul's going to put up his hand. Yeah, big telescopes. Big telescope has enough light to cause the eye to start to work and see a bit of color. Yeah, of course you risk your life being up 7 steps on a ladder, but you remember. Okay, I think that's the end actually, unless there's any questions. Yeah, Paul.
So I used the dye filters when I was first starting to do observing with the 10-inch, and it gave a lot of very detail, especially with the Orion Nebula. Each filter brought out different aspects of the nebula, and it was a really, because I was at St. Croix, it was a dark sky, but I found that in the city they didn't do much of anything.
Yeah, they dim the nebula down
Yeah.
too much to be useful.
But at St. Croix, each filter gave different aspects of the nebula, and it really brought out a lot of detail. But I tried the same thing in the city, and it just didn't work. So
Yeah.
you need a dark sky for them to really enhance anything.
Yeah, except on planets. Yeah. No questions from the they're all having a mid-afternoon break, I think. Coffee break. Okay, thanks very much. Whoops. Oh,
What about those Swan and Comet filters?
yeah, that's one I didn't mention. They're Lumicon started, I think they're made by a few manufacturers now. There's a filter had been sold by Lumicon for a long time called a Swan Band Comet filter. And the intent there was to do the same thing with the nebulae, try to somehow capitalize on colors produced by comet tails so that you'd be able to see comets better. But those of you who know, tried, except for the very brightest comets. Comets are terrible to see, hard to see in a telescope because they appear much brighter, much fainter than their magnitude would indicate. So in other words, look at a 10th magnitude comet through like a 12th magnitude galaxy. So if you can do anything, and what these Swan band filters did, I think, is try to pull out some of that greenish glow that some comets have. They were hit, as far as I know, they were hit and miss. Some comets, it was improved by looking through that filter. Others just wasn't of any use. Does anyone know anything else about those? I've never looked through one myself, but I've certainly seen them advertised. I've heard people talk about them, but they're very much a specialty filter. That I suspect, like if you think back to Hale Bopp had the green, the green color. I suspect that it was trying. That was the wavelengths that it was trying to enhance, was the Ionis thing. glow that comes from comets.
Okay. Thanks, Dave. And there have been some words of thanks through the chat list as well. So just so you know that there are people out there actually listening to us today. Yay. And this time I will make the correct Dave introduction. Dave Chapman is our next speaker, addressing what's in a name and how celestial objects are named. And I'll pass this over to him momentarily. He's been a long time amateur astronomer since what, the age of 10 roughly. He's been a member of RASC since '84. And again, he's another member that has served many roles within our center and nationally as well. And yes, he currently sits on the RASC Observing Committee. I've got the right Dave this time. You did. Not observing. Okay, there you go. Okay, that's where I thought you were. And also, he's on the editorial board, so my apologies. Yeah, Halifax Center, he's still a member of the Dark Sky Preserve Committee. And now I can actually say he's the author of a best-selling book, which I'm sure will mention at the end, partway through his presentation. A word from our sponsor. So here's the box. Here's the mic.
Well, thank you very much. Before I go on to my my segment, I just wanted to make an editorial comment about the last one. No, it's not a negative thing, but I just wanted to say, as a visual observer, I do a little photography, but I guess my watching things evolve over the years is that, especially with the advent of LED lights, because they're so much more efficient, instead of people like saving energy and keeping light levels low, they've taken advantage of the efficiency, and they've made things more bright than they need to be. And so it's kind of had it's kind of had the opposite effect in terms of light pollution. It's the same as they made internal combustion engines more and more efficient, and now they have these bloody big trucks with huge engines because they're so efficient. You can use a lot of fuel. Probably a lot of people are regretting that now. But so what I've seen is that over the past few years, that visual observing, it's getting harder and harder to do because it's harder. I mean, I find it harder to find a dark sky to observe in. And at the same time, technology has made photography much more accessible than it ever was to the average person. I mean, it used to be a pretty specialized thing. Now, I mean, you have to have a few bucks, but it's not hard to get yourself set up to do astrophotography. And we've got a number of people in this center, led by people like Blair McDonald, but David Hoskin, Kathy Walker, Judy Black, if I'm missing anybody, in Paul Gray, and they're making miraculous pictures with cameras, because cameras can integrate for so long. Your eye can only look for a fraction of a second, and these wonderful pictures you see, I mean, they are exceptional. I mean, compared to professional pictures from a few decades ago. But you look at the length of time that these cameras are integrating and passing things through different filters, and then all the processing. I mean, it's just made it much more accessible, and that seems to be where the hobby is going. I guess I'm still waving the flag for visual astronomy, and I really enjoy that, and being able to see things with my own eye. But one thing David said about filters is they can only decrease the amount of light coming to your eye. Okay, they never make anything brighter. Never. They only take away. So even though you've got filters that will help you see one frequency of light versus another, or one wavelength, you still have to be very mindful when you're at a telescope that you have prepared yourself to see dim things, because they're not going to be brighter. So you still have to be careful about looking at screens during the day, having bright lights around you when you're observing, even to the point of, being hydrated and what you eat and so on. There's still a lot of things that you need to do to make sure that your eye is in perfect shape to take advantage of those filters. And I'd like to direct, I can't remember what pages is on, but for the last few years, I've taken over the 2 pages on night vision and how to prepare yourself for observing and the use of eyeglasses and so on. And if you didn't notice that that was changed from what it was before by Philip Roth, it's much more now than it was before. It was just about night myopia. But please go to your 2023 handbook and read those 2 pages, because you know they've been there the last few years, but I haven't had a lot of feedback on them. So please read those. I think you'll learn a lot from them. And now I'll proceed. So I've been doing this series, What's in a Name? You know, the naming of celestial objects, and I've done comets and minor planets, and I did. Oh man, I did the one on the satellites of the planets, which just about killed me because there's so darn many of them. I'm going to do a slightly shorter one today. So what I chose to do this time, and I'm getting to the end of my series because it's getting harder and harder to find interesting things to talk about. But I'm looking at the surface features of the inner planets, inner solar system bodies. And I might, for my finale, do the outer solar system bodies, but I haven't decided yet. But I might do one more, and I think I'm going to be done. Because if I do any more, I'm going to be encroaching on what my good friend Chris Young does with his stars and asterisms and constellations. So the official body for naming things in the sky is the International Astronomical Union. And if you've never heard about them, they're kind of like the United Nations of astronomers. And the other thing you might have heard about is they're the ones that kicked Pluto out of the Planet Club. Okay, so if you feel strongly about that, they're the ones to blame. And there's a working group for planetary system nomenclature. So there's people who concern themselves with such things, and they have rules about how things can be named. And this is what I've been trying to convey in my last few little sessions here, is to talk about the rules and guidelines they use. They don't just willy-nilly choose any old name for things. And so they have rules, and it's quite complicated. And sometimes it takes a long time to have a feature named. So what we're going to do today is we're going to talk about Mercury, Venus, Mars, and the Moon. I'm leaving out Earth. So and you might think, well, Venus, you can't even see anything on the surface of Venus, but we have radar. Okay, so it's all good. So we'll start with Mercury. So Mercury, I guess I don't have to stand here, do I? I could. I can't see my own screen, but anyway. So Mercury has a number of different features, and these are the rules for naming them. So Mercury almost looks like the moon when you first, see a close-up picture of it. It's got lots of craters and plains and so on. You can mistake it for the moon. So the catenae are the radio telescope features. Now, what are catenae? They're ridges, right? Catenae, yeah. Or anyway, craters are named after artists, musicians, painters, and authors who have made outstanding contributions to their field, and over the last 50 years, okay, because scientists and people like that, they've got the moon, okay. The moon is all about scientists, and dorsa are the wrinkle ridges, and they're specifically named after scientists who contributed to the study of Mercury, and you can see all the. I'm not going to read them all out, but the one that I've picked was rupes. Rupes are cliffs. Like on the moon, rupus recta is the straight wall, so a cliff is a rupes. And the one I picked out, I'm just going to do one or two examples of everything. I can't do everything, but you can find these things. So so for craters, there's a picture here in false color, and the craters are Munch, Sander, and Poe. Now, I'm pretty sure Munch is a painter, Edgar Munch or something like that. And Poe must be Edgar Allan Poe. I'm not sure who Sander is. If anybody can help me with that, I didn't really look into it in great detail, but I couldn't think of anybody called Sander. No? Anyone? Somebody's Googling it. Let's move on to the Rupes. The Rupes are cliffs, and they're ships of discovery or scientific expeditions. And I chose Discovery Rupes because Discovery was the name of a ship. It was the name of one of Captain Cook's ships, okay? He had the Endeavour and the Discovery. And so here we have a picture of the cliff known as Discovery, okay? And it goes right through some craters. So there was a bit of a fault there, fault line. We'll pass on to Venus, I think. So Venus got a lot of features that we can't see because you need a radar. And so generally speaking, they're named after goddesses of the hunt or moon goddesses, sea goddesses, so on. The one I chose, oh, Sander Crater, named after the German photographer August Sander. Thank you. Thank you. At home now. Did you? I'll look at it when I get there. So the category of valleys, and there's two categories: the short ones and long ones. And the long ones are named after the name for the goddess or planet Venus in various world languages. And the one, Baltis Vallis, oh gosh, have I forgotten what the, oh, this is Iranian maybe, or one of those Middle Eastern languages, Iranian or something like that. I've forgotten. Maybe can somebody help me with that one? Anyway, but it's the name for Venus in that language. And we'll move on to, I guess, what's the next one? Did I do the moon next? Mars. So Syrian, close. Mars and Martian satellites. Well, the original features on Mars, of course, were mapped out by some long ago astronomers. So we by Schiaparelli and Antoniadi and big people like that. And and then there's rules for other things. Like there's a lot of features on Mars because of all the rovers and the orbiters, and most of the craters are unnamed. So the craters, the small craters that are 50 kilometers and smaller, are named after small towns and villages of the world with populations of approximately 100,000 or less. And so there's obviously a lot of villages, so they'll be able to name a lot of craters by them. So the one I chose was Arandes crater on Mars. Is there a Nova Scotia one on Mars?
Yep.
I didn't know that. Which I guess so. Cancel. Well, blow me down. I didn't know that. I should have. There would have been a better example, eh? Okay. No, I think Arandes is a town in Russia, or maybe the former Soviet Union, somewhere in the former Soviet Union. But there's interesting. There's actually rules for surface features on the two satellites of Mars, which I threw in for. So Deimos, which is terror, Greek word for terror. Authors who wrote about Martian satellites. There you go. Can't be too many craters on Deimos. And Phobos, scientists involved with the discovery and the dynamics of Martian satellites. So something to do with the satellites, or for some reason, Jonathan Swift's Gulliver's Travels. Now, if you recall from last time, Phobos and Deimos are they're the sons of Ares or Mars. They're the sons. I think they might be twin sons, and they carried Ares into battle on his chariot. And, so That's cancel. Thank you. Well, it's great having a guy like you here. Just like, it's like having a personal assistant. Yeah. So where's the spaceport?
Maybe that's why they chose it.
I had a friend went up to Guysborough County after Fiona, and I said, "What does it look like up there after the hurricane?" He said, "Well," he said, "Oh boy." Anyway, he said, "Well, I'll tell you, they're going to save a lot of money clearing the trees." He said, "Up near Canso to make the spaceport." Yeah, yeah. It was programmed to turn off. Well, the next one's just the moon. No big deal. I can say it without showing. So the moon, most of the features on the moon, the craters especially, are named after scientists, usually dead ones, almost always dead ones. There are a few features that are named after other people. Like there are some small craters named after the 3 Apollo 11 astronauts, Armstrong, Collins, and Aldrin. Yes, and I think only Aldrin is the only one left alive. And I'm if it comes back, that's great. But otherwise, the moon, people are pretty familiar with the craters on the moon, and that finishes the surface features of the inner solar system objects. And I'll let you know if I have the energy to continue. So since that's over, now a word from our sponsor. Okay, so many of you know that myself and Cathy LeBlanc have just published a book, Mi'kmaq Moons, which we've been working on the project for 9 years and the book specifically for 4. And finally, after much trial and tribulation, it is out and selling very well. We had a big party last night out at the Mount St. Vincent, and there was a small delegation from RASC there to show the flag, and I thank you all for coming and being a part of that. It meant a lot to me to have you there because the RASC nationally and locally has been very supportive of that work. I was very moved because the elder Albert Marshall from Escazone opened proceedings with a prayer, and later on actually said some very kind things about the work that Cathy and I have done, and that means a lot to me. So I didn't cry, but I almost did. Anyhow, books are selling well, and I had a box. I have a portion of a box. I do have some books with me today in case anyone wants to buy any. They've been signed by both authors and in this case, the artist, because Loretta Gould, the Mi'kmaq artist that did the illustrations, was there last night, and we got her to sign a bunch of them. So if you buy one of those are real collector's items because there's only going to be about 20 of those around. I don't know if we'll ever 3 of us get together again to do that signing. So anyhow, after the meeting, feel free to come over and have a look and buy if you like. I also happen to have copies of the book Moon and the 7 Bird Hunters, which is a Mi'kmaq Sky story. It's not by us, but it's been around for 10 years, and I do have copies of that in case anyone would like those. Anyway, thank you. Oh, suppose I should ask if there's any questions. Yes?
Dave, just echoing from Pat Kelly back on the Martian craters. He indicates that there are 3 from Newfoundland and Labrador that are listed as well.
Okay. I guess I probably should have done more research for this one. But it was actually kind of difficult to get specific examples, but thank you, Pat Kelly. All right, I'm done then.
So when I first started this presentation, I started off with a very serious title used from the National Council. I figured, how droll. So I asked my sidekick, I need a a lighter title. And he said, well, why don't you have one similar to John Reed's title, about 50 things to see about or whatever. So I said, okay, that's great. 300 things to know about the RASC National Council. Yeah. Dave said that'll bring them in. Yes, that is so true. So I said, well, okay, so it's really just 3. And I'm not presenting this as Judy Black, president of the Hoskin Center. I'm presenting this as the representative of the National Council Forest Center, who just happens to also be the chair of the National Council at this point in time. So for those of you that are not familiar enough with what the National Council is, its purpose is basically to advise the society board and committees on matters of interest to the centers and to the society as a whole, and to facilitate our goals and missions. Its membership comprises members from all 30 centers across the country, and there's 1 rep for every 200 members or any part thereof of that 200 in each center. For instance, our center has 1 rep. Larger centers may have 2, 3, or even 4. There are at least 4 meetings per year and at least 1 consultative meeting with the board, usually held at the GA. Some of the people in this room and some of you out there in Zoom land attended the virtual RASC GA this past June. You can see it there circled. It was 100% virtual. And as you can appreciate, when there was an announcement made at the GA, that was the tipping point across the country. Well, what was that tipping point? It was the AGM announcement of the RASC member fee. That lit up quite a few people across the country. Discussions right across the board. Here locally, through our own board of directors discussed it. We heard comments from our members, and that happened all across the country, as well as discussion lists on the 2 special forums for the National Council and for the president. And as a consequence of that, in early July, I had a discussion with Charles Ennis, who is the current president of the RASC. One of the suggestions that had come out of the discussion lists was, why don't we have an FAQ or a frequently asked question document that we could produce, send it off to the board, and have them answer these questions? Because I'm sure that every center across the country has exactly the same question. So I innocently agreed, okay, let's, I'll consolidate, what's the word I want? Yeah, I'll consolidate all the questions, take out the comments from the questions, and develop this FAQ. So we sent out an email to the council and the presidents through their distribution list and said, this is what we want. Here's the deadline for comment. Consequent to all that, there was an open letter sent on August the 16th, late in the evening, called the Open Letter to the RASC Board of Directors from the National Council. It was co-signed by myself and from the president of the Ottawa Centre, Stephen Nurse. Stephen's center very eloquently phrased what the rest of us across the country had wanted to say, but he said it so beautifully in about 2.5 pages. So we used that as the open letter and used as the appendices, the frequently asked questions. And one of the other things we did was we copied verbatim all the comments that were made from all the people that had sent in their comments and questions. So they knew exactly what people were thinking in every aspect. So basically, the key points or the main concerns was how dare they raise our fees given the abysmal year of service that we've had in the past year, right? Delivery of the calendar, the observer's handbook, Sky News. Seemed to be a lack of communication across all levels in the organization. Collaboration wasn't there, and transparency was out the window, if you'll pardon the phrase, especially related to financial pieces. And there were lots of questions related to these three things in the FAQ. And I said, the 300 things, but there were only 3. The 3 words there that are in that brown gold: communication, collaboration, and transparency. Those are the 3 key things that we're focusing on. So 2 days later, within 24 hours, the National Board had met and they agreed to inviting Stephen and I to a board meeting. And within less than 48 hours of that open letter being sent out, I heard from Charles Ennis to invite us to that special session. So, now and on September 11th at our National Council meeting, and keep in mind with this discussion on the 18th, I'd also told Charles that the board had to do more than just acknowledge receipt of that letter. They had to let the National Council know what they planned to do about it so they could see a plan of action. They just couldn't say, yes, thank you, and walk away. And that's exactly what they did. Charles, as well as Phil Groff, who's the executive director of our board, of the RASC, and other board members did attend. Yes, they did acknowledge it, but they also confirmed desire to work with the National Council to build on those three things: the communication, collaboration, and transparency. They notified members of the invitation to Stephen and I, which the membership would have not have known at that particular point in time. And they reminded members of the Finance Committee invitation, in which the board has invited treasurers from any of the centers to join the Finance Committee nationally, because they've recognized that according to the terms of membership in for the RASC Finance Committee before, it comprised basically the RASC board members. And if you looked at who was sitting on it on this current board, none of them were financial people, except the chair, who was the treasurer. So they wanted to incorporate that collaboration. They're asking now the centers to participate in that. So they reminded us of that. So huge step forward there. Also on October 15th, that's Stephen and I down there. I won't tell you which one's the black sheep. But yes, it was a good day. We did attend that board of directors meeting. We did address the contents of the open letter. They asked numerous questions for clarification of that letter and some of the questions that we wanted. And in terms of the open letter, that was the sort of the precursor to the FAQs. We reiterated the major concerns, which are those basic three areas, and discussed possible solutions. Okay, they weren't something that we were going to say, yes, we want you to do this about that. It was maybe we could do, so that they had things to think about. And we identified those three areas of concern. And as you can see at the bottom, we emphasize the fact that improved communication is critical. Okay. So on the 21st, keeping in mind at this point, this is 6 days after the meeting with the board, the National Council and the presidents and other members of the community at large did not know what was going on in terms of, they didn't know the outcome of that October 15 meeting. So Charles and I and there were a lot of, to be honest, some negative comments and criticism. So we said, okay, we've got to let the membership know this is the beginning of the communication piece, folks. So Charles and I sent out a joint statement to both the National Council and to the presidents about information about that October 15 board meeting, what had transpired, the recognition of those three key areas that needed work, and the reiteration of that invitation to the center treasurers. We wanted to change the thinking, and this is part of the message we gave. We want to change the thinking of them versus us to we. Okay, because right now the society seems to be divided as to how we see sort of the leadership versus us out here, and we don't want to see that. We want to see them come together and view it as us. We also have to pool our expertise across the country. We have 5,000 plus members with all sorts of expertise in all the areas that we certainly need in order to build the society into a stronger one. So we're looking towards that, and we'll give you examples of how we've started that already. And we have to work as a team. I mean, those of you in the center, especially on the board, know that I always refer to us as a team. We work together because we all have a common goal. So we have to be, in order to reach it, we want to work as a team so that the RASC can change to become the society we want it to be. It can no longer be what it was. It has to change. So the first piece, that communication piece, this is the knowledge factor. By letting folks know what's going on, it improves our knowledge of what the society is doing. Such as, we need better communication, like I said earlier, through all levels, from the board to the National Council, from the board to the presidents, from the board to the members. The weekly bug report for people in this center I have been forwarding those out. Should have received 2 of them by now. I just sent one out late last night, so you will receive the second bug report that Phil Groff has sent out regarding the driven database. And also here at this level, hopefully we'll be able to improve our communication to our membership as well. Perhaps it hasn't been as good as it could have been or could be, so we're going to look at that. And the piece that we told the board is that we don't only want to know what's been done. That's nice to know. We want to know what you're doing and what you have done. But also critical to this communication piece is, what are you working on? So that we don't have to keep bugging you. Well, when are you going to do this? When are you going to do that? Tell the network what you're doing. And in this way, we can all figure out what it is you're working on. I don't have to bug you about it because I know it's on your list to do. Oop. And as Albert Einstein once said, any fool can know. The point is to understand. And so through that communication piece, that's what we're hoping to do, is to make sure that folks understand what it is we're doing and why. The second thing to know is that collaboration piece, which is the expertise, remember I mentioned earlier about pooling our knowledge with 5,000 plus members. Well, we have done something. We've got a center's manual that will be posted hopefully sometime soon, and it'll be on this side of the website so that it's not you don't have to log in as a member to access it. Anybody in the world can access it. So that's one of the changes we're looking at, what can be put up front without having to be a member and what things are privileged for members. We're developing for the first time National Council position descriptions for chair, vice chair, council recorder, and for the representative themselves. We have to review the National Council terms of reference because our role is changing and how we're doing business within the organization is changing. Driven, a RASC member volunteered to work with developers to work on issues or to work with RASC on the RASC side if there is a need. Well, if you read the weekly bug report, that person is being utilized. It's a member from out west, and he not only has volunteered, but now he's actually going to be doing it. I can't remember his name. It's a guy out in Alberta. He's a gentleman that works for a city and works in the software development and that sort of thing. So he's into that sort of stuff and test software. It was sent out late last night. Okay. Okay. It was sent, really. And then in the future, certainly policy development, program development, whatever else that we need to work collaboratively with the board with, we are certainly going to do. Yeah, I don't think people heard what Greg was saying, but he found it strange that in the past, he found it strange that they had to bring someone in from outside, so to speak, one of our members, someone with some expertise in this area, versus before when it was RASC and Driven working together, but now he feels that it's gone to us and them, if I paraphrased it. Well, as you can appreciate, Greg, there are several things wrong with the Driven program that haven't been fixed. And so this person it's still, basically the fellow is part of the RASC team. So there's the RASC and the Driven team that are still working together. They've just added another member to that team. Okay, so he's not seeing as someone exterior being that us and them. It's still, my understanding, he's a volunteer. Yeah, as far as I know, but I'll have to look at the wording on the bug weekly to see how they phrased it. Well, we'll have to wait and see. Yeah, yeah, yes, that too. The third thing that we wanted to work on is transparency, which is that trust piece. I feel that many members across the country have lost trust in the organization in terms of their ability to manage things the way that they should be managed, and that goes across all aspects of the organization. And so by building in some transparency pieces, such as the financial piece, hopefully we can rebuild that trust amongst members. There is the invitation to the center membership. The Kingston Center treasurer has volunteered, so he is now part of that financial committee. So we do have a link to our centers through that. The RASC treasurer and board members will be attending our December 4th meeting, to discuss budget planning and to let us know more about the status of the driven system as well. So they're involving us in that budget planning process. The RASC updates that we all get weekly and then the monthly updates, that is another format in which they are improving that communication piece, but also hopefully building in the transparency to what they're doing. And one of the key pieces that we're hoping to improve over the coming year is that improved communications at all levels. As I mentioned before, from the RASC to the board, to the National Council, to its members here locally, the same sort of mechanism to make sure that everyone is kept informed and up to date. So where from here? It's a work in progress. Keeping in mind that it took us basically from 2012, which was when the RASC restructured according to the CRA and the Canada Not-for-Profit Societies Act. And the National Council, they didn't know quite what to do with this, how we were to relate to within the organization itself. That is changing. We are having National Council reports at our board. As the rep, I'm certainly do that, and my predecessors have done at board meetings. But at our last board meeting, it was agreed that the national rep would also provide updates at this meeting so that members were kept apprised. So that's part of that communication and transparency piece. If you have any questions or concerns, contact the president, which means I could be contacted as president only for the next couple of months. But then thereafter, I will certainly remain as your NC rep. So you can certainly reach us through that way. And to get the correct emails, just go to our website to contact us under halifax.rasc.ca, and please let us know. I will also let members know that if you have a complaint to make, I want to hear it. But I would also truly appreciate it if you could offer a solution, if you know of one that you could suggest. That's not to say that we would necessarily take your suggestion, but it would be helpful. And please know that your comments will be brought forward. They won't be put into a blank piece of paper. As a member of the RASC, one of the things that I feel really strongly about is that I think with the board, the national board that's currently sitting, and with the members in the National Council, that everyone is really looking forward to working together. It was a very positive experience on the October 15th meeting with the board. There wasn't anyone there that I would say was a naysayer as to what was put forward in that 12-page document in the open letter. And I think some of them even made the comment, or one of them even made the comment that what was there, they've known about for a while, but didn't know what to do about. So now we can work on it. So that's a really big step forward. So thank you. And that's all I have to say about National Council. But again, I'll take any questions from the room or from Zoom, if anyone has any. Yes, Tom. Tom?
So this is just a suggestion. Every week, sending emails out, every second week. Because not everybody, I'm in this position now. I'm in a place, obviously, we're nowadays, where period. You get run eviction and so on. I'm becoming a victim of. So basically, my brother has Wi-Fi and all that stuff, but probably the place I'm going to next for cost wise. They like about every second through, like as costs go up, believe me, I even got to consider this for future meetings, maybe cutting out even cable, like you say, as costs go up, who's like say you got to consider what do you absolutely need. This is thoughts. I'm not trying to attack.
Certainly. No, I take that comment. Thank you very much. I know it's been commented before that I send out too many emails. I'm trying to figure out a mechanism right now as to how we can improve that communication piece without me inundating you. I'm trying to reduce it, for instance, when we get the weekly bug report, to if there is something else to go with it, I try to send out news from the center versus here's the weekly bug report. Here's a reminder of the meeting. We've got calendars for sale. I try and consolidate everything I need to say. So I make a list at home of what I want to say at the end of the week, if there is something at all. There might be another mechanism by which we can post the weekly bug reports on our website, for instance, as an example, that then members can access if they anytime they want and date it each one, so they can go back and look at and refer to these more readily. So that's a suggestion well taken. Thanks, Tom. Yes, Dave.
I guess along that line, yeah, I mean, bug reports may give I shouldn't say give the impression. They indicate that things are being done, but most of those bug reports are not relevant to individual members. So I kind of wonder whether they, the team at National that's managing these things, maybe they should be more open about what the issues are and publish on the national website the issues and the tracking there, so that it's something you can go look at, but you don't actually have to get individual members don't have to get emails about stuff that doesn't really interest them.
The bug reports come through the National Council Forum and the President's Forum.
Right.
And as the president, I guess I made the decision that it was important for members to know at this point in time what was being done, because a lot of the criticisms are about the database.
Yeah.
And the errors in it.
So yeah, okay. I have just a
but there-
general question that I didn't read the open letter, but I can imagine based on the last year what some of the things that were in it. But I guess my question is, as part of that, was there any discussion about, I guess, a disconnect between what the board and the staff deems to be important things to spend their time and effort on versus what the society's members think? And I can think of a couple of projects run nationally that, a tremendous amount of human and dollars are being spent. Now, of course, a lot of those dollars are raised money, through donations, but I don't see a lot of accountability about what the outcomes are. And I've been very critical privately, mostly, about the decision for the robotic telescope, which we know costs, I don't know, 30 or 40,000 a year, just in 30,000 just in the rental fee for the space it sits in, and there's not a lot of outcome. I mean, they run some teacher here and there, but what is the what's the cost benefit? As an example, the average member has no connection with that, and never, and the other distraction that I would say would be the telescope museum that, no one's going to visit. Let's be realistic.
You mentioned two things that I don't think there was any one email that came in when we asked for input that did not mention those two. And tied in with those was the fact that as our fees are going up as a member, you're saying that these are member services. And one of the things that was suggested is that the RASC needs to define what is a member service, number one.
Yeah.
And number two, when it comes to anything that we do, the Dorner Museum, the robotic telescope, for instance, we give out the Explore the Universe to new members coming in. Okay, we've done this. What's the cost? What's the expense? And what is the benefit of having this piece? Is it actually truly a member service, or is it something else? to your point about the museum, the question constantly came up is that once Randall leaves, what then? Because he's the historian, and he's really the one that is personing this or manning this,
Yeah,
I guess.
I mean,
should say.
I guess I wonder
at the
whether
expense.
anyone is actually asking the hard questions. I mean, it's
Yep.
one thing for a donor to come along and offer a pile of money.
Yeah.
But if it doesn't, sometimes it's better to say no. If
Yeah.
it becomes a distraction to what, if you can't keep the staff, can't keep continuity of staff, and you can't provide the basic services of publications to members, and you're distracted by all of these other things that may come with money, independent. And I don't view either of those member benefits, to be honest. I think they're parts of have been deemed to be part of our mandate, but I think they're a huge distraction on a limited capacity to manage.
Yeah,
Yeah.
and your concern was raised right across from coast to coast.
Yeah.
Everyone has the same concern in terms of with the personnel, maintaining long-term personnel and not just through contract. And the person hours that it takes to manage all these projects that are we currently have. And it goes into we really have to hone in what is really important to the RASC to function as a society and for its members. And if this is superfluous and we need to get rid of it, then let's not think twice and let's get rid of it. But it has to be evaluated. If we do this for the membership, it costs this. It brings in this amount of revenue, if any, and therefore, why are we doing this if it costs us more than it brings in?
Or it doesn't. I mean, I personally don't have an issue with the robotic telescope if it has a solid educational program behind it that has more than 10 school classes using it a year across the country. That's great. But if it is not, if it's $1,000 per kid served, then clearly it's not a good use of
Yeah, and that was one of the things we pointed out is that the general membership is typically not using it, and is it truly being used for research other than through the school program? Yeah, so it has to be reconsidered for all those reasons. Just a second, we're handing off the mic to another member.
Further to that, it just seems to me that the board considers all these things as noise, and they listen to it and they continue on the same way that they are going, instead of recognizing that, well, when they got the $1 million for the telescope museum, that's gone into general revenue. There's no guarantee that that's going to be there, and probably donors' concept was that I'm going to give $1 million to the museum so we can build the museum, and then we can have the money in place to run it for the next 20 years or 50 years. But it's in general revenue for the RASC, which is a concern that I see, that, like it's just the same thing. And I hope you make some progress, Judy, and maybe this is too early for the comments that, that I'm saying, but this is my feeling, is that they're going to continue on their merry old way and just consider maybe even National Council is noise. And that's not good for any organization.
Yeah, no, they heard from Stephen and I. We didn't hold punches. Stephen was very good at expressing just what you said. Great, thank you for that. There are lots of things that we see need clarification, change, where monies are going in terms of where they're being reported and how they're being utilized. It really is. I mean, it's a huge issue, and like I said, it took us basically 10 years from that change in 2012 to get to this point. So it's going to take a little while to get this all straightened out. But like I said, I'm really hoping and I'm very optimistic that changes will be made, and they will be made for the better. It'll just take us a while. I mean, even at National Council, I've told people that when we met in June, that we were looking, for change, but don't expect it by the fall. It's going to take us a while for these changes to be identified figure out how they can be fixed, and then to do that implementation, and then evaluate it. Is it working? Is this what we wanted it to do? So it's going to take us a while, but I think there's enough people in the system now on the board and on the NC that really want this change to happen, and that we're willing to work together and find people that will help us do it. So. Oh, don't worry. I followed the model of our board, and they have an action list at the NC now. So that somebody is tasked with something, they have to report at the next meeting as to what the progress is. So they're not off the hook. Okay, thank you for that. Dave, I need your help moving the. I'm finished with this one. Okay, so next up for the speakers is Paul Heath. And Paul is who I refer to as our resident poet. And we haven't heard from Paul in a little bit, but he is a longtime member of our center. He's served many roles from president to observing chair, outreach chair. I always get those two confused. They both start with O. And I refer to him as our ever ready bunny when it comes to outreach, because he's, especially with the youth groups, he's quite key with that. So Paul's poem is called Painted Images, and Paul, I will let you introduce it.
Okay. This poem I wrote partly to recognize Dave and Kathy's new book, but at the same time, over the last few months, the World Asterism Project has been publicly put out there, national support, and also the discovery of Hipparchus star catalogs hidden underneath very old Christian documents. When they were trying to photograph the documents to preserve them, they discovered these were underneath on the manuscripts. So it just brought a lot of things to mind, and I've worked with a lot of First Nations communities over my lifetime in different jobs and placements, and I just felt I was trying to give a tribute to them. Charles Ennis, the president, but he's also the I&D committee, and we've worked together quite a bit over the last few years to develop diversity within RASC. And basically, this is my response to him saying thanks for the poem. Over the last few months, even as I step back from many astronomy activities, there's been an upsurge in the recognition of ideas and ideals of many First Nation groups around the world. The World Asterism Project, Dave Chapman, Cathy-LeBlanc's Mi'kmaq Moons and Two-Eyed Seeing book, the discovery of Hipparchus' star catalog buried beneath an old Christian manuscript, have given the world an opportunity to see back in time to when only the stars and the moon lit up the night sky. These tales passed down through the ages by each culture can now be given to all. It is hoped that they will breach distances that we have put between our planet's cultures, and with luck and hope may bring people together to seek each other's heroes in the stars. My poem is a small attempt to recognize and to thank those that did the work so many have been a part of, and to bring the past back to our awareness in our lives. And I'm just glad that I'm getting such a good response to the poem. And over about an hour's period yesterday, I was a bit shocked. It went back and forth, I guess, around national, and now they're going to publish it with the original startup, the for the World Asterism Project. My poem will be part of the initial presentation in Sky News. So that's the biggest publication my poem has ever made. It made it to. So it's really a cool thing, but it happened so fast yesterday. It was a big shock. But anyway, let's go back to the poem. Judy will explain the pictures in behind after. Oh yeah, okay.
The picture that you can see there faintly in the background is actually painted on the wall at Alma in San Pedro at Atacama, and it's the Milky Way. And as you can see, the two animals at the top there, a llama and its baby. and the llama's name is Yacana. And for the people of the Andes, the Milky Way is a river in which they observe various animals shaped by dark spaces between the stars. And in this instance, they saw a llama nursing its baby. Yacana meandered in a river that ran through the middle of the sky and descended to earth at midnight to drink water from the ocean when no one could see her. And if she didn't drink this water, the entire world was to be flooded. So that was the story of that particular picture.
Mm.
So go ahead, Paul.
Painted images. In ages long past, sages and storytellers paced the embers' fading glow. In villages scattered across the lands, upon the stars, heroes and creatures, great and small, were painted images across those glittering skies. Woven as they passed, morals within each vision were held up by the stars, retold through the ages long as embers faded before the dawn. In ages past, with patient measure, motion of the glimmering firmament unfurled on papyrus and stone, recorded where once only grand images across the sky were realized. Then the fires were not left to die. Embers' focused quiet was lost in the glare-filled skies. Yet sages and storytellers whispered still of heroes and creatures upon a star-filled firmament. We reached above the skies. Glory witnessed filled our eyes. Now sages and storytellers once more are sought. With an artist's brush and an elder's touch, stories bold and morals retold. On pages now, the painted images flow. Embers focus quiet. Now upon the page, in cloudy and sun-filled skies between the glittering stars we seek. As painted images refill the skies, sages and storytellers' tales, yet again enrich the mind. So it's my tribute to all the presentations. So,
Thanks,
and
Paul.
I'm amazed it's getting published.
Congratulations.
Other than no notes. Thank you.
Well deserved.
Wow.
Yeah. The comment from the room, and that's why you're hearing laughter, was, what do you mean other than Nova Scotia? Oh, Nova Notes. Well, that's Nova Scotia. No, Nova Notes. So yes, so he will become known across the country. Okay, next up is David Hoskin with What's Up in the November Skies. So while David's coming down, Dave will change the presentation. Yeah, the two Daves. So while they're doing that, I'll just make a comment. We haven't heard any comments from people out in Zoom land, so we're working under the assumption that our first hybrid meeting may in fact be a success. So I'll reiterate what Dave said at the beginning of the meeting, which is if you have any comments from both sides, from people here in the room as well as the folks out in Zoom land, if you have any comments or suggestions for improvement, and your criticisms, we'll take those too. Please let us know. Okay, and I'll pass it over to Dave.
Okay, so what's up for November? Days are getting shorter. My computer's set up for enter. Days are getting shorter. Tomorrow, standard time becomes in effect. You get an extra hour sleep tonight. But it's it's lighter in the morning, but darker earlier at night, which is good for observing and astrophotography. So sunrise on November 1st was 7:52, and the end of the month it'll be 7:29. Sunset 6:03 at the start of the month, and with the time change 4:35 at the end of the month. In terms of the sun today, this is I took this off spaceweather.com this morning, and you'll notice that there are some nice sunspots on our nearest star. And the one to watch is the one that's just coming around on the eastern limb that I circled in red. That's quite a large one, and it may result in some solar activity that gives us northern lights. The sunspots that are currently facing the Earth are stable fields, so there's very little solar flare activity currently going on. Yeah. It'll change a bit from day to day. So that sunspot that's coming around will advance, maybe a finger or two widths if you hold up to the, but generally it's not going to change from one day to the next too much. Okay, so the question was about how often it updates, and Michael says about every 3 hours. Yeah, it moved in a little bit, yeah. So anyway, that's something to keep an eye on. The moon, well, we're past first quarter. River's freezing over moon. Anyone that's looked up, like last night, if you looked up at the moon, you would have noticed Jupiter fairly close. The 5th and 6th, we've got a meteor shower coming up, the southern Taurids, but with the moon being so bright for most of the night, not the best opportunity for viewing meteor showers, although the brighter ones might still appear. Key date is November 8th, which is the full moon, but also total lunar eclipse. So if you get up early, you can look at a total lunar eclipse on the 8th. And so far, the weather looks like it'll be good. That may change, but fingers crossed. November 9th, the moon and the Pleiades, the Seven Sisters, are fairly close together. November 11th and 12th is the peak of the northern Taurids, so another meteor shower out of the constellation Taurus. The 16th is the last quarter moon, and the next day, the Leonid meteor showers peak. So that's a good early morning meteor shower, and not a lot of moonlight to disrupt it. The 23rd, we have a new moon, the chief moon or the winter moon, and the end of the month, the first quarter of the chief moon. So this is something to look at middle of next week, so the 9th, which I think is Wednesday. You'll see a couple of really few interesting things. So there's the moon, and moon just past full, and very close to the to M45, the Pleiades. And there's also going to be 3 orange objects in the sky. So Mars is quite bright now. It's coming close to opposition at the end of the month. And then we have Aldebaran and Betelgeuse, red supergiant stars, and it's going to be quite striking. So a triangle of red, the Pleiades and the moon. So again, if it's clear, worth going out and having a look. Just to remind folks that are doing Explore the Moon, the time around the first quarter is a good time to look at various craters and mare as part of the Explore the Moon or Explore the Universe programs. And of course, if you don't mind getting up early, around the time of last quarter is also a good time. But this is a more civilized time to do it. Okay, so the total lunar eclipse, it begins, partial begins, the slide I took off in the sky.org, the top figure, and it shows where one is best situated to see the whole eclipse versus seeing just part of it. And we're not in that optimum belt, but we do get to see the start of it. So partial eclipse begins just after 5 a.m. Totality lasts from 6:16 to 7:41. So just before sunrise. If you've got a good western horizon, you'll be able to see the moon in total eclipse. Partial eclipse ends at 8:49, but moonset for us is at 7:06. So the show's over by 7:06, and actually before that, because it'll be way too light. Planets this month. Well, we've lost our chance to see Mercury and Venus. They're both too close to the sun to be visible in November. Mars, on the other hand, is getting brighter, and it's rising earlier. So it's rising in the late evening, and by month's end, it'll be minus 1.8 magnitude. It's commencing its retrograde loop as we approach opposition. Closest approach being at the end of the month, December 1st. Jupiter's still bright. Lots of people have been imaging Jupiter and observing Jupiter and the Galilean moons. Magnitude minus 2.8. It's there in the sky all month, well placed in the evening, and on the 4th it'll be close to the moon. Saturn rises before sunset, and it's best placed for observing just after sunset, because it sets in the west later in the night. We've missed its close approach to the moon on November 1st, but we get another chance at the end of the month for a close approach of Saturn to the moon. Uranus is visible all night, magnitude 5.6. So conceivably at a dark sky site, visible to the unaided eye, but certainly easy to find with binoculars. Its closest approach to Earth, opposition will be on the 9th. And on the morning of the 8th, it'll be close to the moon. So if you're up looking for the total lunar eclipse, that's a good time to look for Uranus. And Neptune is visible before midnight for all of the month, quite dim at magnitude 7.8. The demon star, Algol, Beta Persei, this month is a good weather permitting, good time to see the dimming and brightening of this star due to the orbit of its companion. At 8:55, it'll on the 23rd, it will be at its minimum magnitude 3.2, and then a few hours later, at 12:25 in the morning, it'll be at its maximum magnitude 2.2. So you can see the dimming and the brightening all in kind of one night, and still get to bed by 12:30. Explore the universe. This is the last month for the autumn constellations, and Judy, you see I put the new third edition up there. Pegasus, Andromeda, Cassiopeia, Perseus, and Aries, all worth checking out to complete this these objectives for the Explore the Universe program. Autumn stars, the ones with the N after them are good for SynScan alignment. So if you've got to go to Telescope and you have to tell it tell the computer where you're situated and allow it to build its view of the night sky, those are the stars. It's worth knowing where they are. And the autumn deep sky object for November is Messier 31, the Andromeda Galaxy, and even from suburban Halifax, you can find it quite easily in binoculars. So next month we'll be moving on to the winter deep sky objects. Double stars. This isn't a autumn double star. There in the Explore the Universe program, there's only, I think, one actual autumn double star, and then there's a bunch of winter double stars. So I've been actually taking a couple of the summer double stars and highlighting them here. So Beta 1 and Beta 2 Capricorni are a nice binocular double star, but because the constellation will be setting well before midnight, you want to look for these double stars just after sunset, where they're high enough up in the sky. Interestingly, they're actually 5 stars. So Beta 1, Dabib, I pronounce that right, Dabib, Chris. It's not a double star, but Beta 2 is actually a binary system, and each of those stars is a double. Kind of neat. Beta 1 is an orange giant, Beta 2 is a white giant, so they're pretty easy to find. And a challenge, if you happen to have a telescope with reasonable aperture, is to look for this morning comet, C20B2, comet ZTF. I know Dave Chapman's taken a picture of it with BGO telescope. I took this time lapse with my 6-inch reflector. So if you've got probably an 8-inch Dob, you might be able to find it. Its current distance from the Earth is 400 and nearly 450 million kilometers. By September of next year, it will have not quite had that distance, so it'll be at the closest approach to us at that point. But the projected magnitude is not going to be that much of a change. I think it's going to be estimated projected magnitude would be about 10.5 versus the 11.8 currently. So that's a tough challenge, not a binocular challenge, but worth peeking at. And that's it for November.
Questions for Dave? Okay, thanks for that, Dave. So as you heard, Dave is encouraging us to get up early in the morning.
Get a dog.
There is that aspect. If you have a pet, you certainly have to get up early in the morning to service the dog. Could that be the right way of putting it? I don't know. To help the dog. Yeah, and it's the same presentation. As has been the habit, we always give an update from the board at each meeting so that you know what's happening, and also to focus on some of our stars across the center. First and foremost, Tim Doucette. He's been featured twice over the past few months. Tim, in Fox News, his time lapse of a asteroid that had exploded on the atmosphere, and that was the dust trail as it came through. It was an absolutely incredible piece that came through on U.S. News. And thanks to Lisa Ann for advising us of that one. And Tim recently, and his Deep Sky Eye, won the Tourism Business of the Year award down in Yarmouth. So congratulations, Tim, on that award. Well deserved. In Earth Sky, there were 2 of our members. Again, the 2 Davids. David Hoskin with his picture of the Pleiades M45. That was taken at the Skull Barbecue. And Dave Chapman that Dave Hoskin already mentioned about his 2022 E3, and that was the picture I believe that you probably took here, but it was also in an article in Earth Sky that was originally written by Don Mackholtz, rather, sorry, who has since died. Terry Trees in the U.S. edition of the Observer's Handbook, and I don't know if we have the same cover in Canada as we do in the States, but I'm assuming we do. Terry is the coordinator of the Urban Observing Program of the Astronomical League, and his program was referenced in it. So congratulations, Terry, for that recognition. And I know Dave Hoskin pointed this out in his images, but I found this one in Astrophotography Nova Scotia, and I thought it was such a phenomenal photo, I just had to feature it. We also like to recognize those dear souls who have actually finished one of the certificate programs, and Rob Fanning completed his Explore the Universe certificate, his very first one. And I apologize to Rob for such a late date for recognition on his accomplishment, but congratulations, Rob. And more currently, congratulations to Elsie Ferguson, who just this past month completed her Explore the Moon telescope version. So congratulations to you both. And also, of course, Dave has already mentioned his book on the Mi'kmaq moons. That was a photo taken last night at the presentation of Dave with Cathy LeBlanc and the illustrator Loretta Gould, and I'm assuming that's her daughter that was beside her. But it was a phenomenal event. For those of you across the province, those are various places where you can actually purchase the books. Let alone the folks in here can purchase it this afternoon. The photo contest, I want to remind people that it's dates coming up really quickly. Today is the 5th, and the contest closes 1 week today. We need your photographs. Believe it or not, we only have one entry so far in the whole contest. So all those photos you took over the summer and this early fall, please get them processed and submit them under the categories of wide field, solar system, deep sky, or prime focus. And there will also be an award as in subsequent years for the People's Choice Award. The winner will be announced at the AGM on December the 3rd. So how to enter, just go to our website, and if you go look under imaging, it'll have the contest there. So please submit. We really would like to be able to award prizes, but if the submissions aren't there, heaven help us. So please submit your incredible photos because we know you've got them. Oh, by the way, to enter, you have to be a member of RASC Halifax Centre or be a resident of Nova Scotia. Nova Notes. This is the latest edition that Lisa Ann and John put together. Congratulations to them both. It's an incredible issue. If you haven't read it, please go to it. It's on our website. The deadline for submissions to the next edition is Saturday, December 10. So please submit. There is something new in this edition. It's called Puzzle Corner. These are reprints from puzzles that were printed way back when. And so we decided it'd be a really cool idea just to have these puzzles so they'll keep members engaged and thinking about astronomy. Each puzzle for the next 5 editions will have a different focus. Okay, so something to do on those when you're waiting for algal to dim or brighten. Our election is going to be happening at our AGM coming up, and we need nominations for all positions. As you can see, the president's position is still vacant, and we do not have a nominee for it as yet. The treasurer position is italicized because we did have someone volunteer to have their name put forward for election. But as always, we take nominations for all positions. If you would like to volunteer to have your name put forward for president, we'd love to hear from you. Otherwise, please contact Peter Hurley, who is the chair of our nominating committee, and you can reach him at secretary@halifax.rasc.ca. And remember, it's by Saturday, November the 12th, that we have to have these nominations in, which is next week, because of the timelines within our bylaws that we have to have the names out to all our members prior to the AGM. As always, we'd like your participation at our meetings in any capacity that, if you have a topic, observing strategies, observing sites, serendipitous moments, maybe even become the MC of our meetings so that you can introduce the speakers. That would be helpful as well. And you don't have to do it every month. Maybe you can say, okay, I'll take June's meeting, whatever. We're welcome to one at a time. Also, our task teams and subcommittees that will be coming up. It's a team effort. I truly do believe that teams work well and support and back each other. You learn from each other, and it's always fun. Never a dull moment. And there's the list of committees that we could use membership on. So if anyone's interested in any of those, again, advise us, and we'll certainly make sure that you become part of that team. Heads up meetings. Most important one coming up at the end of the year, the AGM on December 3rd. Our first meeting of the year is January 4th. We haven't got any meetings established past that for now. But given this one is a success, I think we can assume that all future meetings as well, at least for the near future, will be held through Zoom because it affords us the ability for those who can't come into the city, like John out in PEI, for instance, who can't come, but he can attend through Zoom, so he can continue to attend our meetings. They will be hybrid. Yep. The January 4th meeting, by the way, I believe the focus of it is youth. We have 2 youth speakers, and I'm about to invite the 3rd again to see if it's, so it'll be a youth day. Explore the universe. Dave showed the booklet in his presentation on what's up. I do have copies of it with me today, so if anybody would like a copy, they're $20, or if members out there, let us know and we can get that for you, but contact us and we'll let you know what the expenditures are for shipping above that. And on top of that, we have the 2023 calendars. We have them in our possession. The incredible photograph on the cover is Tim Doucette, his photo of the Iris Nebula. So congratulations, Tim, on that. But when I opened up my copy, trust me, people, I was jumping up and down because I couldn't believe this. I mean, as Halifax Center president, I'm really thrilled to show you the following. In April, you'll see Fiona Morris, and this is Fiona's 2nd year in a row that she's had a photo in the calendar, and it's her photo of the Leo triplet, and I just identified the 3 that are in that. And then if you wait till June, you have Jason Dane and his copy or photo of the blue horse head. And then unfortunately, the summer you can take a break, but wait till you see the fall. You've got October, Kathy Walker with her Messier 5, Tim Doucette with his Iris Nebula, and December is another one of Jason's with the Melot 5. So 4 out of the 12 months plus the cover are from Nova Scotia. Woohoo! So really thrilled about that. So get your copy. I do, like I said, I do have copies here, and we contact me and we can mail them to you. We'll give you the particulars. Any questions? Yeah, the comment made for those of you out in Zoom land was that Paul Gray said there was no bias in the selection of those photos at all. And if you noticed at the very beginning, I said that Chris Beckett was the editor for this, and Dave mentioned just because he was a former member of Halifax Center had no relevancy whatsoever. Okay. Well, that concludes our meeting for today, folks. I want to thank everyone for attending on both sides in terms of here in the center and out there in Zoom land. And 4:16, so we didn't do too badly time-wise.
Zoom land.
There we go. Okay. So, well, again, thank you one and all. Much appreciated. Same time, same station on December the 3rd. See you then.